Hello, class. On a rainy Tuesday here, I'm going to start recorded lectures for Chapter 3 in our stats class. And we're going to do the first three sections of this chapter as well. And the first section, probably the most important, talks about measures of central tendencies in data. So basically what we're looking for is ways to define what the middle is of all the data. And we have three terms that we will be discussing. One is mean. Another word for that is average. The second one is median, which is the middle point of the data set. And the third one is mode, which is the data point that occurs most often. So let's start with mean, and the one that's used probably the most with regards to measuring central tendencies. And the idea of a mean, and this came out of the book, and I thought this was kind of a nice image. It's the idea of if each one of your data points was a weight and you were on a seesaw, all right? If you think about a seesaw, where if you want the seesaw to be completely horizontal with regard to that, you're looking to put the same amount of weight on both sides. And that's kind of what you're looking for here. If you think about the physics, this would be the fulcrum point where you would stick it right in the center where it would be perfectly balanced on either side. And the idea of this calculation hopefully is a review to most. But I do want to point out again that there is a difference between statistical analysis of the total population and if you're just doing a statistical analysis on this sample. And so you'll see that when we walk through these calculations, we're going to give you equations for both. Some of them are the same and some of them are slightly different. My personal feeling is I always deal with samples, so I always use the sample calculations. But as a strictly statistical class, I want to make sure we talk about both of them. And so the population mean is with this Greek letter mu, which is a weird looking U. And the sample mean is X with a bar over it. And the good news about mean, again, is average, is the calculation for both population and example is exactly the same. You'll see that when we get to variance and talk about standard deviations, they are slightly different. And when n gets really big, the number of samples, you'll see that they virtually are the same number. So the good news is we're going to use the letter N for the total number of points in your data set, either population-wise, where we use capital N, or sample, which we use little n. And so basically you add all those numbers up and then you divide by the total number of data points. So in the example that we gave, you would take these five numbers, which was 78, 83, 92, 68, 85. These five exam scores. You add them all together. And since there were five of them, you divide by five, and you would say the average is 81.2. So you'll see that when the number set is small, you can get out your calculator, it's not too bad. But when the number set is big, it's a pain to do by hand. And again, I will show you how to use spreadsheets to do all this. And what I'll do is I'll download some information from our Alex homework assignment as well to kind of show you how to get that all set up when we do that. The second set of data, or not second set of data, but the second way to measure central tendency is to find the middle point of the data set. And that means the value that's right in the middle. And that's called the median. And the median calculation is set up, same for population and sample again, but the strategy depends on how many data points you have. So if there is an odd number of data points, then the value is right in the middle. And so you could see for this example, if each star is a data point, we have 7 data points there. And so you could see there's 3 below and 3 above. So you could see that the median right here is right in the center. It's point number 4. If there's an even number, you could see that the point would actually be in between these two, which obviously isn't a physical point, and it needs to be a value in the data set to be a median. So what we do when there's an even number, as you can see here, there's 8. We take the middle 2 and average them together. So you would add these together and divide by 2. So let me show you a couple examples. So the strategy here is you can see that we have 5 data points again with these exams. So if you're doing this by hand, the strategy is you want to arrange them smallest to largest. And then you figure out how many data points you have. Here we have 5. So it's an odd number. So what you want to do is you want to take the center point. And you can see that this center point here would be 83. There's 2 below 83, and there's 2 above 83. So if you have a lot of data points, sometimes it's kind of a pain to count up 50 and down 50 with regard to that. So one formula that I don't think I've seen this in the book, but you might, I will share it with you, is, for example, here, if the total number of data points is n, right? That's the data points. And n is odd. To calculate the point where it's the point in the data set, the median occurs, you would take the value of n and divide it by 2. And then you have to add the number 0.5 to get to the integer level. So for example, on our data set here, the first one we had was 5. So that would be 5 divided by 2 plus 0.5. And so that would be 2.5 plus 0.5. So data point number 3 is our median. And so if we went back over to the data set that we had here, you could see that that would be the 83 with regards to that. That's the third data point with respect to calculation of the median. So here's an example of 8 data points, and here this is an even number. So to calculate the median for an even number of data points, we want to average the middle 2. And so again, the first strategy is you take the data set, if you're doing this by hand, and putting it from smallest to largest. And so here's our arrangement. And you can see that the 2 middle data points are the 19 or 15 and 19. So when you add those together and divide by 2, because there's only 2 data points we're averaging, we would get 17. So the strategy of calculating what the 2 data points are let's erase this up here, and what the 2 data points are if it's even. So the way I like to think about this, instead of odd now, we're going to do even. So what we want to do is average the 2 middle points. I'm a math teacher because I can't spell. And so the first point position will be n divided by 2. This is position 1. And then the second position, or the second point, would be that point, and you just add 1 to it, and that would be position 2. So in our example, we had n equals 8. So the first point is 8 divided by 2, which would be 0.4, so position 4. And the next one would be 4 plus 1 would be position 5. So if we go back to the data set, you could see that the position number 4 is 15, number 5 is 19. You add those together and you get the median for regards to that. So you'll see in the ebook and in some of the slides, it gives you some ideas on how to do these calculations using the TI-84. I believe the 83 is very similar to that as well. So take a look at that if you want to use your calculator. I will be focusing on using the spreadsheet for these calculations, and you'll see that the spreadsheet data is available in Alex as well. So I think it's way easier than trying to type all this stuff in your calculator. But of course, if you are, really want to learn using that calculator, the book actually does a pretty good job of explaining it. So what I'm going to do here is compare the different properties between mean and median. And then I'm going to end this lecture and talk about mode and then go through some spreadsheet calculations. So the interesting, and again, this is from the book, the interesting thing about median is this idea of, they use this term resistance, is that a statistic, or in this case, the mean or the median, is a value that's not affected much by the extremes. And so the way to think about this is that the median isn't going to move much if the extremes are really big, where the mean, because you're adding them all together, actually moves quite a bit if the extremes are really big or really small. And I think the best way to think about this, let's not deal with the slides anymore, but the best way to think about this is, I think that when you're doing exam scores, those are typically where you usually don't have really low scores, because I don't put the ones that get 0 in there, that don't take them, and with regards to the very high scores. So the extremes aren't super big. So what you're looking for here is probably mean is a very good measure of the center. And usually your data set is very well defined if the mean and the median are really close together. Now, something, for example, as net worth, or how much money people have, say, in the US of A. Well, here, there are a small group of people that have a ton of money. People like Bill Gates and Warren Buffett and Jeff Bezos, and they're worth billions and billions and billions of dollars. So if you use them and add everything up, they're going to skew the mean to the high end. So in this case, where there are real heavy extremes, median is a much better measure of the central tendency with regard to that. So typically when you see statistics about net worth or salaries. Usually there's a few people that have a lot high salaries, so a median is usually a good way to do measuring salaries. Measuring home values, where if you had one or two homes in multi-millions and most of the other ones are low hundreds of thousands, then median would be a better measure with regards to that as well. So when we talk about that idea, we introduce this idea of skew a little bit more. Is that if most of the data is in the middle and the two extremes are pretty low and not a lot of data on either side, that's where we call it's symmetric, and the mean and the median are really close together. When the data is what we call skewed to the right, meaning that the big peak occurs at the low end here, you'll see that the median will be below the mean with regard to that. And then in this case, where this skewed data is to the left, the median would be above the mean. So this middle one here, where most of the data is down here, is, for example, the net worth people. Where up in this tail, right? That's where the Warren Buffett and the Bill Gates and the Jeff Bezos are sitting here in the multi-billion dollars of net worth, where here most people are down here with regards to a much lower level. So that ends the first part of lecture for section 3.1, and we'll continue that in the next